Hi, Kaushik. Can you hear me?
Good evening, sir.
Hi, good evening, Kaushik. And we have also Prasanna Ram. Prasanna, are you a new candidate?
I joined a month back, sir. I'm giving safety first, so I was not active for a few days.
Okay, no problems. Yeah. You have motor and MEP left also. Is that correct?
Yes, sir. First will be safety, naval, and electrical. Next month I'll
Okay.
be giving motor ME.
Yeah, no problem. Yeah. Which MMD again?
Chennai, sir.
Chennai. Okay. Who is there in Chennai now?
Not sure, sir.
Uh-huh. Mr. Venugopal is still there or not?
I've seen his name quite a few times in
Yeah.
questions.
He's a cranky person. Okay.
Uh, but these days his name is not coming that much.
Uh-huh. Okay.
Kamath sir's name is coming a lot, but I'm not sure if he's from Chennai or somewhere else. Krishnan and Kamath.
Mr. Kamath was from earlier, he was in Mumbai. Then I think now he must be in Chennai. I'm not sure also.
Then Murthy, sir.
Sorry,
Murthy, Mr.
Murthy.
Murthy.
Okay.
In Chennai, overall, only these names are coming. I think Kamath is in Mr. Kamath is in Chennai now.
Mm, okay. But anyhow, no problem.
I
So
heard he is good.
yeah, should not be a problem. I think Mr. Kamath was in Cochin before. I'm not sure. I just remember this name. Or was he in Calcutta? A bit confused. Okay, so Prasanna, so to start with, we have begun with the dry docking. So we have had two classes. So one was just the introductory class, and the second one was regarding the dry docking requirements and dry docking preparations. This is what we have covered so far, right?
Okay, sir. Okay.
Yeah. So I'm going to cover further things from here onwards. Yeah.
Okay, sir. Yeah. Recorded sessions are available.
Sorry.
Are recorded sessions available? First two
Yes,
sessions.
they are available. Yes.
Okay, sir. Okay.
Yeah. So finally, we are going to start with a new topic, that is the stern tube. So when you go to the dry dock, there are few things that you happen to check, right? One of them is the stern tube, right? Uh, so before we go to the stern tube itself, right, I would like to share my screen. Uh, okay, can you see?
Yes, sir.
Okay. So when a vessel is going to the dry dock, so it is going to the dry dock with certain conditions. Okay. So there are some tank conditions, stability conditions, and so on. Right? Why that condition is required? Why I cannot go to the dry dock with just like I want?
Sir,
Can I go?
during the critical period, reaction force will start acting, buoyancy will reduce. It will have reduction in GM.
Actually, yes, that is the reason. Okay. So ideally, I would give you three scenarios. One, you enter the dry dock with no trim. Okay. So forward draft and aft draft, they are the same. Okay. The second condition is that you go by trim by aft. This is zero trim. This is trim by aft. The third situation would be you go trim by forward. So which condition is the best for me? Is it zero trim? Is it trim by
Zero,
aft
sir.
or is it trim by forward?
Zero trim should be ideally good because the entire keel will rest at the same time and reaction force will be distributed.
Right. What about trim by aft?
Generally, we go trim by aft, but I don't know why.
Okay. So what happens? Ideally, this is the right thing to do. Okay. Why this is the right thing to do? Because, hold on. That is because if you look at the ship construction, okay, the aft part of the ship, okay, only that one I'm drawing. The aft part of the ship where this is there. So this is the deck plating, right? And this portion is called stern frame, and it happens to be like this. And from here, there is something called a coffin plate, right? So when you have something like this is additionally strengthened. This is one member, okay? And this is the backbone of the vessel, ideally, okay? And this is the most strongest part of the vessel. Why this is the strongest part of the vessel? Because when you go trim by aft, right? And when you have a block, this is the first place that when you are deballasting in the dock, this is the first place your stern frame will come and rest. If you happen to look at the transverse section, okay, like this, and this is the block, okay, this is the midship. So stern frame, that is this area, that is the one which is first resting on the block. It is because it is additionally strengthened and it can take so much of stress, okay, so without deforming. That is why this is made additionally like this. It is made of a bulb plate. Okay, it is not a normal plating that is simply welded. It is made of a bulb section. Okay. So ideally you come trim by aft. And when you are coming trim by aft, okay, so what happens? The vessel is something like this. Okay. And this is the first place your blocks will be like this. Okay. There will be many blocks. So first place, this will be sitting here. And from here, because now you have touched down on the block, what happens to the buoyancy? Are you gaining buoyancy or
Reduces.
you are losing buoyancy? What happens? The buoyancy reduces, right? So when the
Yes,
buoyancy, yeah, go ahead, go ahead.
sir, buoyancy will reduce. Yeah.
Correct. So when you are touching down here, right, on one point and on one single point, right, the buoyancy will reduce at this particular point. But there is buoyancy at these points. Okay. Now, in the process, you are also deballasting now. So you are throwing water out of the dock. And that time, the whole vessel is coming down. So it has already touched down. Plus, you are pumping out water and you are causing a loss of buoyancy more and more. So from the time that your stern frame has touched this block until the time it is sitting on all the blocks, right? That period is called the critical period. Because what happens ideally, why it is called critical period? Because if you have a vessel like this, and if this is a single point of contact and you are losing buoyancy, what will happen? You can topple on either sides, correct? You can topple, right? But let's say during the critical period, you had one of your ballast tanks like this. Okay. If this is empty, that means the weight distribution is okay. Both of them will contribute no weight. But this one had some liquid and this one was empty. So what will happen during the critical period? All the chances that this will be going to this side, correct? And if there is a free surface effect, you know what happens, correct? So that is why when you are going to the dock, there are certain conditions to be met. That is the forward draft, aft draft, what is the trim, what is the tank condition, okay? How much bunkers in which tank you should have, how much ballast you should have. Should you have no ballast? So everything will be advised by the dock master. He will tell you the tank condition and the plan. And you have to maintain that tank condition and the plan. That is why when a vessel is going to the dry dock, you will see on the last voyage, they may not supply any bunker. They will ask you to consume everything and have only in this service or settling tank. Okay? Do you understand?
Yes, sir.
Yes, but why not even keel?
Sorry?
Why not even keel?
Yeah. So
As
that is a good question. Why not even keel? So what happens? Okay. So we have frame numbers. Okay. Starting from the aft until the forward, we have the frame numbers. Okay. Now, under each frame, there is a block. That is how the blocks are placed. You will never see a block which is in between the two frames. Okay. Because of the stresses that it will cause. Because frame is the strong point. Now, the cross section of these frames are not as good as the stern frame. Okay. So, if you have an even keel here, right? If you have an even keel, so all the weight is coming like this at the same time. Okay. Now, when all the weight is coming down at the same time, what will be the reaction forces on each block? How much will be the reaction forces on each block?
it would be reduced, no? Uniformly distributed load.
Okay. Which block will have the most reaction force?
Maybe near machinery space, since we'll be not having any cargo.
Correct. So this obviously this part. Okay. So this part will have most of the reaction coming, right? Now you have a difference in reaction if that is the case. Correct? You have a
Yes,
difference
sir.
if there is a difference in reaction, let's understand it the other way around. So more force acting here and less force acting here, right? So you wouldn't predict what will happen to the stability of the vessel, which way it will go. Okay. Whereas a gradual touchdown is generally a good procedure. Okay. So if all the blocks, right, are touching down together, right? Also, one part is that the monitoring part, it becomes difficult, right? So what happens? Ideally, there is a diver underneath. So he will say touchdown. Touchdown means the stern frame has touched the right block. Okay. And not only that, when the stern frame is touching the block, can I confirm that only this point has touched and the remaining part is still floating? That is correct, right? The
Yes, sir.
remaining part is still floating. That means if I was touching down all together, right? Number one, my reaction forces will be different. Number two is that if the blocks were not aligned, I will have to ballast again and float the vessel again, correct?
Yes, sir.
That means I will consume extra time ballasting, deballasting. Okay. In this case, this much buoyancy I already have. This part of the buoyancy is something which I already have. And if the touchdown is not proper, I can only ballast this section. I mean, a deballast, pump water into this section. Only this can be floated and adjusted, correct? That will consume less time than actually the whole thing being floated again. Do you understand?
Got it, sir. Thank you.
Right. So one is the reaction forces. That is very critical. The second thing is the time consumed in ensuring that block is actually touching down as per the frame number which is decided. Okay, it is important. Your frames have to be on the block. Okay.
So forward 15% length is also made stronger for bounding effects.
Forward part. So there is a difference between the forward part and the aft part. Let me draw separately. Hold on. So this is the aft part. Okay. So as I told you, there is a stern frame with a bulb section, which is coming like this. And it is really a thick section. Huh? Even if you do the extreme tensile test and all, it will withstand any load. It is that strong. Okay. And it is the strongest part of the vessel. Whereas the forward section, how it is made? It is made from here until here. This is called the nose plate. This section is a thick section. Okay. This section is a thicker section. Okay. Now, this section and this section, they are not the same cross section. This is a bulb plate. This is a nose plate. Okay. They are different in construction. No doubt they are thicker sections, but the nose plate is not as withstandable as the stern frame. You cannot imagine a vessel which can, and some vessel, they have bulbous bow. So this is an extension of now the nose plate is here and the bulbous bow is here. Bulbous bow is a buoyancy member. It is not a strengthening member. Your strengthening member is here. Understand? Even if you have a bulb puncher, you can still sail the vessel. If you have a nose plate puncher, probably not. Okay. And why this section is strengthened? Because you have a collision bulkhead here. Somebody has to withstand this strong collision bulkhead, no?
Yes,
Right.
sir.
So ideally, if you have a bulbous bow, you can't do a forward trim already. It is not a strengthening member. It is just a buoyancy providing member. Understand?
Yes, sir. Okay.
Yeah, just hold on. I am running down on my battery. Let me plug it in. Okay, shall we now move on to the stern tube part? Right? This was just information.
Sir, can I ask you a question, sir?
Yes, yes.
Sir, in case we are going for a dry dock for the repair or the damage to the hull in the same site where we are strengthened, that coffin plate and all. So what will be the substitutional position in case of entering dry dock?
Once again, I could not get your question.
If we have the damage, we are going
Mhm.
for the dry dock for
Yeah,
repair in the
yeah.
F1 side only, in the coffin plate side or the stern frame side. So there should be any another option to go for dry dock, the framing positions, the position of the block, or only this is the I mean trim by aft is only the position we can enter the dry dock.
Well, it is not a rule that you should enter the dry dock like this. Okay. But 99% of the cases, this is the fact. And what I understand your question is, so you are asking like this. So this is a vessel where there is a damage here, correct?
Yes, sir.
How do you enter the dry dock? Correct.
Then in this case we can go even keel, right? With
No. So what has been done? So I have faced a similar situation like this. So in that case, just to reduce the stress part and all, because this part was already damaged. Yeah. Maybe in my hard drive, I have some photos. I need to dig it out. So my case, it was like this. I will show you. The damage was here. Okay. So ideally, you could not dock because there was a big hole gaping over here. And if the stress was more, obviously the whole section will buckle. Right. Now this becomes a little bit complicated. But the solution is very simple. What they do is, I will show you the transverse section. Okay. So they make ballast tanks, dummy ballast tanks on the side, which are providing buoyancy. So these are called buoyancy tanks. Empty completely. They will weld it here, weld it here, weld it here. Right. Now, because these are buoyancy tanks, right? Can I reduce my stress here?
yes, sir.
It is providing me additional buoyancy, right? These buoyancy tanks, they are providing me additional buoyancy. That means they are reducing the reaction. Is that correct?
Right, sir.
So that is what was done on my vessel, where there was the investment is huge, almost 6 to 8 million to weld that buoyancy tanks. But this vessel on which I was, this was completely loaded with cargo. There was no other option. And since it was a kind of damage which was taking in water, and somehow the temporary repairs and everything was done. And when we went to the dry dock, so there were no shore cranes available to take this cargo out. In that case, they welded this buoyancy tanks. And from afterward, by the time the cranes and everything was organized, the buoyancy tanks actually helped. Okay.
Okay, sir. It doesn't look ideal. I mean, practicable. It's
See, marine engineering.
yes, sir.
Okay. There is nothing by the book. Only the manuals are by the book. Okay. The marine engineering practice is not by you. Do you have any book on MEP? You will have books on general, motor, where everything is defined. But marine engineering practice is a set of innovation. It is a set of practices which are born with the necessity.
Yes, sir. And situational based. Everything is situational based.
Correct.
Okay, sir. Thanks for.
So that is why you would imagine, अरे MEP में जो क्वेश्चन पूछता है वही मोटर में पूछता है तो अलग अलग क्यों है? No, one is practice. What is the best practice that you are following? What is your situational awareness? Whereas in the motor, you have clear defined procedures in the circular, instruction manual, and booklets, outlets, and whatnot. Okay. Practice, they don't have a book on practice. Share market is a practice. Is there a book on share market? Many. Is there a defined book? ये पढ़ो और शेयर मार्केट में आप पैसा कमा लोगे? None. सब अपना अपना एक्सपीरियंस लिखते हैं, है ना?
Right, sir.
So this is like that. Okay, now jump to the stern tube section.
Sir, for that you was talking about this toppling up the vessel while resting on the keel blocks.
Yeah.
So there are some arrangement is there for holding the ship like a breast shore is called.
Yes, it is there. That
It
is
is
definitely.
used
Now
for
there are
the
two columns.
So some of the
And
dry docks also provides locomotives, both the sides.
yes,
So that could be a better option. Much convenient.
but not all the time. Not all the time it may be required. Okay. Can you hear me? Because it says Zoom quit unexpectedly. Can you hear me?
Yes, sir. Yes, sir.
Okay.
Screen is not visible. We can hear you, sir.
Okay. Okay. Now? Okay.
Yes, sir, visible.
Okay. So what is happening? There are shores. One moment. So why the shores are provided? So once the vessel is completely on the block, right? You might be draining tanks, you might be filling up tanks, and so on. Many other activities will be going on. Okay. So in the dock, if the vessel is like this on the block, okay, additional shores in the form of either in a block. These are the shores, means extra support to maintain that stability. Okay. So this particular shore can be made of wood. Okay. Or it can be made of steel frames with a wooden head. Right. And where it is attached, on the other hand, it is attached to your graving dock. It is attached here. So these are called shores, just to keep the vessel stable during the initial period. Okay. Sometimes they have ropes also. In the olden dry docks, you will find still some ropes are there to maintain that stability. And the vessel, actually, they will adjust the ropes. Okay. Why they will adjust the ropes? If you look at the plan view, then the vessel is like this, correct? Vessel is like this. And under the vessel, there is this blocks. Okay. Now each frame has to sit on each block. Okay. Now imagine if the vessel was not positioned properly. How will the position of the vessel be? It will be like this. It can be like this also, right? Now the vessel can be offline, correct? It will not sit on all the blocks properly. So it has to be in a straight line. So what they will do, they will use the mooring ropes. They will slack this one and tighten this one to align this. Do you understand? Is that understood?
Yeah, center position is also very important.
Yeah, centering basically. Yeah. So all these things are there. Okay. Now going to the stern tube. So I have some videos to play regarding the stern tube. There are a number of materials on the group, on our AIMS group, on the YouTube and everywhere. But important thing to understand and not forget is that the purpose of the stern tube. See what I am trying to achieve in the stern tube. What is my purpose of the stern tube? Can I have a vessel without stern tube?
No, sir.
No,
Is it
sir.
possible?
No, sir.
And why
Because
not?
propeller shaft is passing through the stern tube. We need to their seal arrangement and bearing arrangement. cooling arrangement is required. If we pass directly, then how do we fit this bearing then?
Okay. What if there is no propeller in the vessel? Do you need S20?
No, if you have sail vessel, then we don't no need. Yeah, without
Correct. So open up your mind. There are many barges in the world. Okay, very heavy lift barges which don't have S20. They don't need it. Okay. आप हर एंगल से सोचो. I want to open up your mind in that way. ठीक है.
Sir, if we can have a propeller or motorizing arrangement on the rudder also, we
Propeller, what once again?
propeller, I mean, the on the rudder, motorizing or propelling arrangement from the rudder, stern tube outside the stern tube, not from
Then
the.
also.
Then also we don't need any stern tube.
Ideally, but you will need some kind of seal, right? You may not need a stern tube if there is no propeller and shaft arrangement. But since your now propeller is fixed to the rudder, you are saying, then there you will need a seal in the rudder. There are examples like that. So, has anybody sailed on a cruise liner?
No, sir.
No. Anybody sailed on a LNG with azimuth propellers? Okay, so there was one cruise liner on which I was there, and what they have is that they don't have main engine and things. Okay, what they have is a pod propulsion system. They have a motor and they have a propeller here. In this case, there is no stern tube, nothing. It's not required. Okay, all you will need is a basic seal here. That is it. Okay, this is just a motor with an attached propeller. That is it. Okay, so coming to the purpose of stern tube, the purpose of the stern tube is two. One is that the water should not come inside your stern tube, and stern tube ceilings are there. So the purpose of the seal is that not let the water outside come into the engine room or enter the vessel, or the oil from the outside from the vessel should not go outside. Okay, because we are mindful of the environment also. Okay, so there are two purposes. How these two purposes achieved? Okay, now you have a shaft. We will come to the video very soon, but try to understand in basic school wala terms. You have a shaft. There is a taper in the end of the shaft, and there is a propeller attached. Okay, and your vessel is like this. I will take a different color. Okay. That is how the vessel is, right? So this is the stern tube. Okay. The tube shaft, I mean the tube through which the shaft is passing. That is called the stern tube. Okay. Now this is integral part of the vessel itself. When the vessel is made, the stern tube is basically a big tube made of cast iron, and it is welded to the ship's hull. Here it is welded. Okay. And this is the whole tube. And it is welded on the other side on the engine room bulkhead. Okay. This tube is welded here. Let me take a different color so you can understand. ये अपना पूरा ट्यूब है, which is welded. Where is the engine room bulkhead? The engine room bulkhead is here. Okay. Is that understood? This is the engine room bulkhead, or you can call This is the either cooling water tank. Have you seen a cooling water tank on your vessel?
Yes, sir. It is there in aft side.
Yes.
Top of that, only tank arrangement is there for fresh
Yeah.
water we filled up.
Yes. So there is the cooling water tank on the top, and this whole thing is welded to your stern frame like this, through which the shaft is passing. And let me draw it a little bit neatly here. So you have a shaft, okay? And then you have the stern tube arrangement. This is the stern tube. Now what happens? What I have to do is put a seal here, okay? Like this. How will I put a seal? Can I simply put a rubber seal around it and let the shaft rotate? No, right? It will not be a proper arrangement. So what is done is normally the seal is placed in a seal carrier. Okay. The seal carrier will be here. This is a stationary part. We will go to the video and see, but just understand this is a seal carrier. Okay. Inside the seal carrier, there will be seals. Sorry. We want different color to understand. So these are the seals. Okay. The seal carrier will have the seal. Okay. Now, in the forward also, a similar arrangement will be there. There will be a seal carrier with a seal. Now, is this a good arrangement? This is a good arrangement. What is the risk? You see, this has to work for 5 years, 10 years, I don't know. You know. So what happens? There will be, the medium is seawater outside. This seawater is abrasive in nature. Okay. And every time the seawater is here for a very long time, it will cause the shaft surface to deteriorate. Okay. Can happen.
Yes, sir.
Now, what is done to avoid this? In a pump, in a centrifugal pump, you have a shaft, you have the impeller here, and what do you have here? Shaft sleeve, correct? To protect the shaft, correct? So if there is some problem, you just replace the sleeve and put a new sleeve, and your shaft is protected. Okay. So I put a shaft sleeve here. This shaft sleeve is called the chrome liner. Is that understood?
Yes, sir.
Okay. Now, our new arrangement will be something like this. So, here is my chrome liner. Okay. Sorry. There are two chrome liners, forward and aft, forward seal, aft seal. And then, what do you have? You have the seal carrier on the top. Okay. And then, you have the seal. Okay. You have the seal like this. Is that understood?
Yes, sir.
Now, in between that, what do you have? Here, lube oil is supplied. There is lube oil pressure here. Okay. What is on the other side? There is seawater pressure there.
One question regarding liner.
Yeah, yeah.
Uh, Comparing with the pumps, just like you
Comparing with
made a
the pumps.
comparison. Yes, sir.
Yeah, yeah.
I've seen quite a few times where in the process of removing that piece, we end up spoiling the shaft itself.
Okay. The sleeve, you mean?
Yeah, in the process of removing the sleeve by
Yeah,
heating,
yeah,
especially in boiler pumps,
yeah,
in the
yeah,
process of removing that, we end up heating it and then heating it to remove it as more particles get accumulated and it becomes tight. We end
yeah,
up spoiling the shaft itself, and finally, I've seen installing a new shaft. So
Correct,
how
correct.
is that tackled in this liner?
So here there is a clearance between the liner and the propeller shaft itself. Okay. Because that clearance, it's not like a clearance, I can say, but it is a snug fit. Okay. See, now this shaft will only freeze, this chrome liner will only freeze on the propeller shaft if there is a lot of kachra accumulated between the two. Correct?
Yes, sir, that's what I'm asking about. Like
Okay.
it's a
So,
seawater, so naturally salts will
yes.
could get accumulated.
When we go to the actual drawing, I will show you there is a O-ring here underneath the chrome liner. So nothing enters. This surface is always protected.
So we have O-ring and sleeve also, the sleeve.
No, we have definitely. But the question is, how are you heating it? How did you heat your pump shaft? Can you remember?
Torch.
You should not use that. See,
Sir, what was the
that is
question, sir?
that is
How?
the so what happened, I will tell you. So he's asking a question. This is the pump shaft, okay? And in the pump shaft, there are sleeves, okay? To protect the shaft, okay? Now, here is a O-ring in the sleeve, okay? Here is a O-ring. So nothing will enter between the shaft and other things. Yes, that is correct. Now, what is happening? He's saying that it was difficult to remove the sleeve, okay? So when it was difficult to remove the sleeve, so they heated this by torch. Oh, of course, the science says that if there is a differential expansion, then there will be a clearance created between the two, and this should drop. So that is what exactly was done on his vessel, which is a very wrong practice. You cannot do that. Why you cannot do that? I'll tell you. So when you use a oxy torch for heating, okay, it is not a wrong practice, but it does not work. I have seen that failing in many cases. The reason being, you heat here. Can you heat here at the same time? You can't, right? You can't. Okay. So you have to sweep your torch from up to down. Okay. What is the temperature at the nozzle tip? Almost 1200 degrees Celsius. What is the temperature where the nozzle tip is not there? 350 degrees Celsius. If you don't believe me, you can go on board and actually measure it. Imagine the temperature difference. What will happen to the sleeve? It will only bend. And do you think if the sleeve bends on,
Distortion, thermal distortion.
yes, it will never come out. So there are only two ways to remove it. So one, if your shaft is small, okay, you put it in a container of lube oil. Okay. So there is lube oil inside. And then you heat this container by oxytorch. So the lube oil heat is distributed same at all places. Correct? That cannot be different.
The lube oil has to be heated with torch.
Yes. No, the container has to be heated.
I mean, which container will withstand 1200, sir?
Array, the normal biscuit container. Unless you cut it, you know how the bearings are installed. So in the
Bearings we only heat it to 90 degree, 80 degree.
yeah. So this one also you are heating to 120, 150 degree only. See, the temperature at the nozzle tip is 1200. Okay. That tip you are keeping here and you are heating the oil will be about 150 degree, 100 to 150 degree. You are not heating the oil to 1000 degrees. Okay.
Okay, sir. Controlled way of. Okay,
Yes,
fine.
yes. So
Understood.
you have to sweep the torch under the container, not to make a hole. If you keep that torch for very long, then the container will be cold, all the lube oil will be, hot lube oil will be dropping on your leg. Okay. So there are specialized containers made for it, or you can make one on board with a with a 0.5 mm plate. Okay. A small container you can make, and you can use it for any other purpose also. So use a lube oil for heating for a proper expansion. Okay. That is one. The second thing that you should do, if the best thing that is provided on board, it depends on the owner if he provides it. So there is an induction heater. Have you seen that?
No, sir, but I've heard.
Yes. This is an induction heater. Okay. What do you have to do? You have to keep your shaft on the top. Okay. And there is a plug here. This is attached to your 220-volt supply. You keep the shaft here. Okay. And then you switch it on and you set the temperature. You can set the temperature in a digital manner. And let's say you set it to 120 degrees and then you heat it up. It will heat all the surface in a very even manner. It will not let the shaft distort. And then you try. The majority of the wrong practice is because we are using an oxy torch directly on the shaft. And small deformation of 0.01 mm, that will be very difficult to pull out the sleeve itself. Okay.
Yes, sir, okay. And sir, what in case of actual liner and propeller shaft?
Once
Any
again.
such issues?
Once again.
Sir, in case of liners and propeller shaft, will
Yeah.
there be any issues that we face?
We are coming to it. We are coming to it.
Okay.
Okay. So I will play a video also. But first, with a better understanding, we will understand in our old, very basic knowledge is what are the components and how does it look like. So when you see the video, you can relate. Okay. It will save a lot of time. So as I said, there is a shaft. On top of the shaft, there is a chrome liner. On top of the chrome liner, there is a seal carrier. The seal carrier is with seals. Okay. And that is the arrangement. On this side, you have the lube oil. On this side, you have the seawater. That is the only arrangement of stun tube. Okay. This is the very basic arrangement. Okay. And when you go on board, it will not be very different. Okay. These seals, they are made of, these are also called the lip seals. They are made of nitrile rubber. Okay. They are made of nitrile rubber. And very basic questions people are asking. Do you have to go to a dry dock to replace the seal? No. You can replace the seal while the vessel is afloat. That can be done. Okay. Can you replace the seal, forward seal? For that, do you have to go to dry dock? No. It can be done when the vessel is afloat. Okay. Now, the second question, second doubts in the mind is that now I look at the shaft like this and the seal is like this on the top. Okay, sorry, not like this. The shaft is like this and there is seal around the shaft, right? So there is a seal which is around the shaft like this. That is what is shown here. This particular, this is all around. This is what I'm showing is the cut section. Okay. The transverse section, you will see that there is seal all around the shaft. Now, if there is seal all around the shaft and if there is propeller here, right, then how can you say that the seal, I don't have to go to a dry dock, remove the propeller and then put a new seal inside and then put the propeller back? No, it is not required. We don't need to remove any propeller or something. Okay. In the further videos, we will see how. Okay. Is that clear?
Yes, sir. And that's one more thing, sir.
Yeah.
There is the forward seal, aft seal, and
Yeah.
intermediate shaft bearing. Is there any way bearing arrangement is there in that aft
Yes,
part
yes.
of
Bearing is there.
where the what part
There is
which
a.
part where it is
We,
location?
we will come. We will come. We will come. We are coming there. Let me take out. Hmm. Okay, what we are going to see now is the basic stun tube seal system. So I found one video on the YouTube itself, which he has taken from somewhere and put it here. And it is from one of the maker's manual. That is why I'm referring you this particular video, because whatever the drawings at least he has used is from the maker's manual. Okay, I will send you the link also.
Sir, for the changing of the seal arrangement, we no need to remove the propeller, and we
No,
can we
you
no
can
need
do
to
it
do
yourself.
we no need to come for the dry dock and see if is update
No.
come. But changing of the chrome liner, we have to go for the dry dock.
Yes, that is correct. Okay. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. So this is the basic stern tube system. Okay. Now you see there is this propeller shaft. Okay. Forward to aft. This is the aft seal. This is the forward seal. Okay. Let's look at the aft seal first. So these are the lip seals made of nitrile rubber. And remember, this is a cut section. The seal is all around the shaft. Understand? And you see, this is the seal carrier. Which is the seal carrier? This one. Because this is simply carrying the seal. Correct? This is the seal carrier. Okay. So that seal carrier is in different parts, you can see. Okay. They are in different parts, if you can make out from here. Why they are in different parts, that also we will come to. That is your oral question. Okay. How many different parts? 1, 2, 3, 4. Okay. And each part is bolted together by a Allen bolt. See, there is a Allen bolt here. There is Allen bolt here. Okay. Each is screwed into one another to make it one complete piece. This much is understood?
Yes, sir.
Okay. Now this one, the last part is extended like a flange. Like you have a pipe and you have a flange. Okay. So this is extended like a flange. And that flange is screwed into your stern frame side. Okay. That is the stern tube. So you have a vessel like this. Okay. And you see, it is bolted into your stern tube. I told you, right? It is a welded arrangement, that stern tube, right? So it is screwed there. And that itself is a part of the stern frame. Is that understood?
Yes, sir.
Yeah. And here is the chrome liner. So you can see the seal is actually sitting on the chrome liner. It is not sitting on the shaft. Okay. This is the chrome liner. Okay, and there is the O-ring inside the chrome liner to have any dirt or water ingress between the shaft and this one. Okay. Now, remember which is the stationary part and which is the moving part. What is this? This yellow color?
Propeller bar.
That is the propeller hub. Okay. So you can see that propeller hub, if it is rotating, that means this is bolted here. That means this is also rotating, correct? Yes?
Yes, sir.
And of course, the shaft is also rotating. Okay, because the shaft is connected to the propeller. Propeller is rotating, then shaft is also rotating. If the shaft is rotating, propeller is bolted to your chrome liner. So these are the moving parts. This is moving, and this is moving. Yes? Where is the stationary part? This is the seal is the stationary part. Can we form a seal now? So one is the moving and one is stationary. Is that easy to understand?
Yes, sir. Okay, sir.
Okay. Now coming to the question, why this seal carrier is made into different sections. Okay. So what happens over a period of time is that the seal is rubbing on the chrome liner. Okay. And this can lead to grooving of the chrome liner. Okay. So when the grooving takes place, what happens? The surface becomes very uneven because one is stationary and one is moving. And then the surface becomes uneven, and the groove, it is a, how you call this, cumulative reaction. Once the groove was formed, that will only increase. It will never maintain that. Okay. So now when you see a groove, what will happen? The seawater ingress can happen, correct? Or the lube oil can go out because the quality of sealing is affected. Agree? Boys?
Yes, sir.
Okay. Now, because the quality of sealing is now affected, what is the thing that I have to do now? My seal is destroyed, right? There is groove. So the groove has destroyed the seal. What should I do now?
We need to replace the, sir. Change the position of the liner.
We have to, there are 2-3 ways. Either you replace the seal. Okay. Number 2 is that if you are in a dry dock and if you are taking the chrome liner out, okay, then this chrome liner can be put on a machine and this uneven surfaces, they can be machined and skimmed to make it even. Okay. So when you are machining that, there is a tolerance which is given by the manufacturer. Only this much you can machine. Beyond that, if you machine, okay, the surface will be smooth, but the sealing will not be provided. You cannot guarantee a sealing. So it should be within the tolerance limit. If your groove is already beyond the tolerance limit, better throw that chrome liner and buy a new one. Okay, that is the second method. First method is replacing the seal. Second method is replacing the chrome liner or machining the chrome liner within the tolerance. The third thing is the most convenient thing to do. So now, since this is all in section, okay, what I'm going to do now, the same seal, I'm going to shift its position, okay, somewhere here. Why? Because at this point, the grooving has taken place. But at this point of the chrome liner, there is no grooving, right? Because there was no seal anyway. So that surface is still okay. It is a point contact. So that point is damaged. I'm going to the other point. How will I go to the other point? So now if I remove one section, and put a shim between one of the section, can I shift my seal back here?
Yes.
That can be done, right? Yes.
Yes, sir.
So that is the reason it is given in different sections. So you can place a shim in these sections and you can move the position of the seal to a new point on the chrome liner. Okay. Now, some doubts in the mind. People who have never been near the stern tube. Can you access this from the engine room? No, you can't. Where can you access it? From outside. Okay. So there is a rope guard and all here. You remove the rope guard and you will be able to see this particular seal carrier. Okay. When you see the seal carrier, then you can, take out this particular bolt and you can change the position of the seal. Okay. Last part I am not taking out. I am shifting only these two. That will work for another few more timing until the vessel reaches the dry dock. Okay. So that is possible. Now, the next question is, the seal is only, diameter of the seal is from here to here. But the propeller is this big. How do I insert the seal? From here. The seal is not inserted from here. So what they are doing is, they will cut the seal. So if the seal is like this, they cut the seal. Okay. They take it around the shaft. There is a process called vulcanizing. They join the two ends that they have cut. They vulcanize this nitrile rubber and a bond is formed and the seal is over the chrome liner. Okay. Is that understood?
Yes, sir.
So it is a simple process. So about the construction part of the stern tube, you have already seen and covered most of it. Okay. Now this particular stern tube that I am telling you, it is called the stern tube with a simplex seal. Okay. So these are the simplex seals. Because in simplicity, they are only nitrile seals. Okay. Now you see, is that, one moment. Oh shit, I stopped the screen sharing. Let me put it back. Hold on. Now what we are going to see is the stern tube lubricating oil system. So there is one video again on YouTube, which I will send you the link. It is a good video to understand the lubrication system of the stern tube. And you only follow this for the exam. Okay. For a simplex seal, when we go to air seal, it is a different system. Okay. The same basics. Everything is the same with a very minor adjustment. Okay. That is the air seal. But first we will learn the simplex seal. This is the simplex seal that we are talking about. Okay. Oh, I have not shared my screen.
So this installation of seals by cutting and vulcanizing, this is done by some external party, specialized team.
Yes.
If we are not going to dry dock, so anyway, we cannot go outside and do this.
Yes, yes. So there is definitely a shore team which is coming and they are specialized in doing all this. Normally it is coming from the maker also. So the maker is coming and doing it.
Okay.
Yeah, it is not done by the ship staff because you don't have a vulcanizing tool on board. Even if I give it to you, probably for the first time, it won't be a perfect job.
Yes, sir. Expertise.
Yeah. Okay. So I'm just playing this video. You see, this is the propeller shaft. Okay. And this is the propeller hub with the propeller, right? You see the lube oil system, how it works. So there is a tank. From the tank, there is a pump. Stern tube lube oil pump. Then this is the, what is this? Oil cooler. Stern tube lube oil cooler. You can put it in use or you may bypass it depending upon the seawater temperature outside. Okay. And then after the cooler comes the header tank. Okay. So the pump is pumping to a header tank. Now there are two header tanks. Okay. For two different drafts. Okay. So that tells me that there is a massive draft change in the loaded condition and in the ballast condition. This vessel has a huge draft change. Many vessels you will see there is only one tank. How many vessels, how many tanks were there in your vessel?
One, sir.
One, right? So probably the draft change was not that huge. So here in this particular vessel, there are two header tanks. Okay. So when you go to a deeper draft, you use the higher header tank. When you are in a ballast condition, then you use the lower header tank. Why is that? Why do you have to change according to the draft?
Hydrostatic pressure.
Because the seawater pressure outside is changing. Okay. So now you see this is going there and header tank. This header tank is overflowing to this particular lower header tank. From here, it is going back. This is overflowing to your drain tank again. So this is a closed system, right? Now you see the supply line. So on the bottom of both the tanks, there is a valve and there is a three-way valve. You can turn this three-way valve in either direction to choose which tank you have to put in use. So let's say I'm using the higher header tank. So I'm turning the three-way valve in this direction. So now the lube oil from here will come here. It will come all the way here. Okay. Go to the seal, right? And it will lubricate all the bearings and everything. We will come to the bearing part. It will be exerting a pressure on the seal. It will be lubricating the bearing and everything. And then from the bottom part, this is coming back, right? And it is draining back to the tank. From the tank, the pump is taking suction again. Have you understood this much?
Yes, sir.
Simple, right?
Yes, sir.
Now you see on the drain line, on the line which is coming back to the drain tank, there is a lube oil pressure gauge here. And what is this? This is the seawater pressure gauge here. Okay. Why these pressure gauges are provided?
So, ensuring that low pressure is slightly above seawater pressure.
And how much
So
above?
seawater doesn't enter.
How much above the seawater? So the maker says that you have to keep in any condition, any given condition, you have to keep your lube oil pressure 0.2 bar to 0.3 bar more than the seawater pressure. So if you see the lube oil pressure is 0.3 bar more than the seawater pressure, it is okay. Do you understand?
Yes, sir.
That is why those pressure gauges are provided. Okay. Now there is how do you know the system is working properly? Because there is a side glass. It is all the time overflowing from here. Okay. If this tank is not overflowing, that means the pump capacity is not enough. There is some problem in the suction. So, the oil return or something, this side glass must always overflow. Okay. And each tank has a vent, you see, as normal. The drain tank also has a vent. And here is the forward seal. In the forward seal, in the aft seal, we saw that there is a pump. In the forward seal, there is no pump. It is just mere circulation by the shaft itself. Okay. As you remember, the forward seal header tank, where is it?
Near the stand tube, sir, or near aft.
Correct.
Aft.
It is just on the floor plate level, correct?
Yes,
So it
sir.
is not very high. Okay. So the circulation in the system from here to here, okay, is done by the shaft itself, natural circulation. Okay. And if you remember, this particular tank is finned tank. That means there is an increased surface area to keep it cooled. And sometimes there is an oil cooler also. This is not always the case, but in some ships, yes, there is an oil cooler here also. Okay. Is that understood? Any doubts?
No, sir. But one question, sir.
Yes.
Here we have this header tank with the pump arrangement also there.
Yes.
What I am observing, some ship have doesn't have the pump. Only header tank is there.
Oh, yes, that is also possible. There are some systems like that also.
Sir, any diagram is there? Can you explain this one? How does it work?
Yes, yes. Let's go one by one. If we take
Okay.
everything at the single time, then we will only get confused. Okay, because we have further to see the system with the bearing and the system with the air seal. In that, I will explain why there is no pump, why there is some other system there. Okay.
And sir, one more thing. In the last
Yeah.
ship, what is there? This two pump was there nearby the propeller shaft.
Yes.
But and also two header tank also there. One is the ECR platform, another is the boiler platform. But they are
Yes.
not running. This pump was stopped. So many times I
Hmm.
observed. After that, I asked them. The chief said me that we just bypass it and we are using this only header tank. We no need to run the pump like that.
See, what I will say is that if you are only using the header tank, okay, let's say in this particular condition. So, okay, that means this side glass is not overflowing. Okay, this side glass is not overflowing. Now, that means the level in the tank is below the overflow level. Correct? And the pumps are stopped. Does it serve the purpose? Yes, it serves the purpose. See, the purpose of the tank and the pipeline is to exert a pressure on your stern tube system. Is it exerting a pressure? Yes, it is still exerting a pressure. Okay. Now, if you like to keep it this way, it is not a problem anytime. It is not a problem. Okay. Now, what happens is, if it is simply exerting a pressure, now you remember there is a suction filter here. There was a suction filter, right? Why this suction filter was there? You remember?
Any
So
kind
if,
of particle in the system.
see, if there is any kind of bearing wear or other things which are happening, right? First, you don't know where the level on the tank is. Okay. Because this system is designed for an overflow type. Okay. Are you exerting a pressure? Yes, I am exerting a pressure. Is it overflowing? No, it is not overflowing. So do you know the level in your tank? I may not be knowing. I am just guessing by going by this pressure gauges. Okay. That means this oil is, that means this valve is closed. Correct? This valve is closed. Otherwise, the whole system will drain out to the drain tank and there will be no pressure. Correct? Yes. So this valve is closed. That is how this is exerting a pressure. Now, there is no return from the circulation system. There is no circulation because the pump is stopped and the valve is closed. So there is no circulation. If there is a wear out on the bearing, or if there is a water ingress, or if there is any foreign particle here, will it get accumulated inside the lube oil and remain there and cause the situation to go worse? Is that possible?
Yes, sir. Because no
Yes.
circulation is there, so whatever
Yes.
oil is there, it's like this shaft is only मतलब वो तेल के अंदर डूबा हुआ है, बस घूम रहा है,
Correct.
वहीं पे
Correct.
रहेगा.
So this actually does not serve my whole purpose. It is serving my short-term purpose. स्टर्न ट्यूब लो ऑयल पंप फेल हो गया, कोई बात नहीं, उसको बंद कर दो. इसको बंद कर दो, वाल्व बंद कर दो, इट विल स्टिल एक्सर्ट अ प्रेशर. लेकिन सर्कुलेशन में इफ इट इज देयर, देन circulating oil is better than a stagnant oil, because then you will be able to draw conclusions and your filter will be able to filter out things and not cause the situation to go worse. Is that understood? That is why the
Also,
pump is.
thermal degradation could happen, no, in that part of the lube oil.
Yes, it can. Any kind of degradation can happen. Now, recently on one of my vessel, just a month before, what has happened? So they have done a lube oil analysis. From the lube oil analysis, the content is tin. There is tin content in the oil. Where is this tin coming from?
I think
Sorry?
bearing, tin-based bearing.
Yes. If there is a white metal, what is a white metal? Tin, antimony, copper. If there is tin, okay, where did they find the tin? In the filter. Where did they find the white metal particles? In the filter. Okay. Then I know that this stern tube is wearing off. Okay. Otherwise, ये अगर ऐसा ही system है, not in circulation, it will remain there. The whole lube oil will be full of tin only, because you are not removing it. Correct. I will give you a very simple example. You have a heart in your body, right? Pumping oil. Does the heart have to pump oil? No. Why it is pumping oil? Circulation. Why the circulation is required? Oxygen flow to all parts of the body. If the heart stops, will the blood pressure change? Probably not. But what will change? The oxygen supply will change. Okay. All right. Let's play this video, man. Just watch this video. Can you hear the sound also? Maybe you cannot hear the sound. Hold on. I will try to share the sound. Share sound. Okay.
The lubrication system consists of a drain tank which acts as a reservoir for storage
Can you hear?
Yes, sir.
Okay.
of oil. Drain tank is a double-bottom tank located in the aft of the engine room. The system consists of two sets of oil pumps. The purpose of having two pumps is that if one pump fails, the other pump can take over and continue the operation. Pump draws suction from the drain tank and sends it to the oil cooler. The cooler cools the lubricating oil and maintains the temperature of oil within acceptable limits. The cooling medium used in a cooler is air or water. The oil reaches the full load condition header tank, from where it overflows to ballast condition header tank. Both the tanks have an outlet valve located at the tank bottom. Overflow from these tanks is led to the drain tank via a side glass. Pressure head exerted by the oil level in the header tank and water draught are monitored by noting the pressure gauge values. A drain value is fitted to check water intrusion. The small pressure differential of oil ensures water exclusion. The lubricating oil passes through the stern tube bearing. The oil pressure is sufficient to generate hydrodynamic fluid film lubrication. Since static head generates oil pressure, it is sometimes referred to as static lubrication. The diagram also shows a lubrication system for the forward seals. The oil circulation within forward seals is achieved by natural convection. Oil in the forward seal tank is cooled by a cooler. In some cases, the tank is provided with radiator fins on the tank surface. The air in contact with the fins cools the tank, which in turn cools the oil. You are looking at a simplex type stern tube. The simplex stern tube consists of forward and aft seals. The seals work in conjunction with oil lubricating bearings. The aft sealing assembly consists of two main and one auxiliary sealing rings. All sealing rings are spring-loaded and are able to seal any position of the shaft. The forward sealing rings prevent oil leakage to sea. Spring load and oil pressure of the system. Lip seals hold oil within the stern tube and accept slight misalignment. The elastic lip of each nitrile rubber seal grips the short chrome steel liners. Chrome steel liners are located at aft and forward ends of the propeller shaft. They act as rubbing surfaces for lip seals. The liner at the aft end protects the steel shaft from seawater and corrosion. Scavenge space fire is detected by.
Was that okay? Understood?
Yes, sir.
Okay. Now I will share something else. Can you see this manual? I have a manual on my screen.
No, sir. We can see only the YouTube channel.
Hold on. This manual? Can you see?
Sir, can you rotate it anti-clockwise?
Yeah, all the other pages are like this.
Oh, okay,
That is
okay.
one. Yeah. So now this is the manual from onboard. Okay. So you see, this is the aft seal. So this is the chrome liner. Okay. And here is the seals. When you draw in the MMD exam, you have to draw only a simple block diagram. No need to be this exact. Nobody expects a machine drawing. Okay. So now you see, this is the nitrile seal. Okay, this is the chrome liner and this is the shaft, right? This is the seal carrier, as you see, and here is the propeller. It is bolted to the propeller hub. Okay, and between the propeller and the chrome liner, there is a O-ring. This is number 17. See, rubber ring. That is made of synthetic rubber. It is like a O-ring. Okay, and if I zoom it, then you will see that there is a clearance between the chrome liner and the shaft. Did you see?
Yes, sir.
So it does not get stuck. Okay. And this is the forward seal.
Will there be lube oil in that space?
Ideally, no. There will be nothing.
Okay.
But normally, whenever I have seen the chrome liner coming out, there is oil underneath, always. It can seep over a long period of time. But it is not a problem. It is better if it seeps, right? Yeah. So now this is
Removing this, do we need to do anything or just pulling out it will come?
there are jack bolts.
No,
Okay.
like heating and stuff, that's not
No,
required, no?
nothing. You don't have to heat and all. There are simple jack bolts. You just put that bolts and it can come out.
Okay.
Okay. This is the forward seal. You see this is the oil pipe. This one with the union. And the oil is supplied right between the two seals. Okay. Now you see the seal numbering. This is 1, 2, 3 and 3S. Why this is 1, 2, 3 and 3S? Why not number 4?
Sir, both are in same segment, I think. 3 and 3S.
Okay. But here the segments are different. The number has changed. Here the segments are same. Also the number has changed. Why it has not changed here?
Because of their direction.
No. See, 3S means that S has a special purpose.
Sealing.
It is a standby seal.
Standby seal, yeah.
So that is why, because the seal is not in use. Okay. Only these 3 seals are in use. Okay. And that is why this is 3S. That means this is standby. Okay. So here seawater pressure is acting. Here there is an empty space. There is ideally, in ideal scenario, there is nothing here. There is seawater pressure acting on this. So 1 minute. So when the seawater pressure is acting on this one, it is pressing it down and sealing. Here nothing is there. If the seawater happens to be in this part, it will again press down and it will seal. Okay. Now, if the seawater is here, ideally here also nothing should be there. But if there is seawater, there will be seawater here and there will be low oil pressure here. Okay. Now there is a differential pressure of 0.2 bar or 0.3 bar, as I already told you. Okay. So ideally, the water will not be allowed to come to inside. Is that understood? This much is understood?
Yes, sir.
Sir.
Sea levels
Now,
of barrier for seawater and
yes. Okay. Now, what I want to ask you next is that, let me zoom it. Now, as we said, there are 3 levels of barrier. Here, here, there is seawater here, there is low oil pressure here. Okay, that means there is low oil pressure here also, right? Okay, but this is tending to lift the seal, correct? It is not trying to seal, it is trying to lift the seal, float the seal, correct?
yes, sir.
But the fact is that there is low oil pressure here also. The same low oil pressure. So the pressure here is same as the pressure here, and both the pressure cancel each other, and the seal becomes a floating seal.
Area has to be
Understand?
equal, no, sir.
Sorry?
The area has to be equal on both the sides.
Yes, the area is equal. If you look at the profile, the area is equal, right? So this becomes a floating seal. That means this seal is not in use. Why this is a floating seal? Is because, let's say, this fails. This fails. Now this is also starting leaking. What should I do? I should put this one in use. How do I put this one in use? So when the oil is entering here, it is entering through a valve. All I have to do is just close this valve. So the low oil pressure is here and the pressure is not here. So this seal starts sealing on the chrome liner. So the standby seal comes into action. Is that understood?
Yes, sir.
So what is the emergency operation? Put the standby seal into use. So when, I know in the market there are many other answers floating that, okay, I will raise the level of the lube oil in a 200-liter drum and all. Yeah, you have to be very unlucky that all your 4 seals should fail. And you should be a really dumb engineer to wait for all the seals to fail. Because this progressive failing takes a very long time. After all, it is a mechanical object. And mechanical object, it does not fail over a 1 single second. It is not electronic. It is mechanical. Tried and tested. Okay, so this fails over time. So if you have already waited for the last seal to fail, and that means, yeah, the seal is not the problem. The engineer is the problem. Okay. So the purpose of 3S is understood?
Yes, sir.
Yes, sir.
So that is why it has a different name. It is not number 4, it is 3S.
So the wise answer for the emergency operation of twin tube system would be to start with this, putting 3 as in use. And
Yeah.
only if that fails, which is very rare, then we go for the drum arrangement above the header tank and increase the pressure.
Yes, yes. See, in ideal scenario, I have had many chief engineers calling. I got the lube oil analysis report. Report is bad. There is water in the oil. And he's panic on the phone. So I normally ask him, Chief, why are you panicking? There is water in the oil. I accept it. But what is the percentage of water? Can you tell me? Then he's lost. Then he go back, he checks his lube oil analysis report, and he comes back and says 0.3%. Is that something to be panicked? For that, should I stop the
Some
vessel?
replenishment will remove that percentage.
There is nothing that you have to do. The limit of 1% is allowed. And this man is sitting at 0.2, 0.3%. 3 o'clock in the morning, he calls me, there is water in my stern tube.
So, but that is good now that he has observed, because now he has noticed that the water ingress is starting.
You take any stern tube system and tell me there is not 0.1, 0.2% water. Have you seen that happening?
No, certainly we get that.
You will not find a vessel with where there is water percentage
So
0.
what I meant to say is, comparing with previous reports, if there is an increase
Yeah,
in just
and
a quarter or two, then it
that
is a situation to be taken care of.
that would have been a very good approach if he had approached the problem like this, if there is a rise in trend. But this man calls me and says that there is water in the stern tube. So what do I take it as? The whole stern tube is full of water. So that is why I ask him, what is the percentage? How much it has been in the last report? Is it same? Okay, then why are you panicking? Then he says, okay. So as I told you, this is marine engineering practice. And practice differs from person to person. Okay. But in the lube oil analysis report, if you look at that, there is a warning sign which is coming. It is an alert. It does not say that your stern tube is a problem. So understanding of the report is very important. See, there is an alarm in the engine room. What do? You run to accept the alarm, correct? Is that correct?
Yes, sir.
Why do you run? Do you run to troubleshoot the problem? No. You are running to silence that buzzer, which is going blah, blah, blah all the time. But after silencing the buzzer, is your speed the same? No. You are going at your own ease. Correct? So all the hurry that was there to silence the alarm. and the actual troubleshooting is at your own speed. So does it make sense? It doesn't. Okay, but that has been our practice, what to do. Even if I was in some engineer's place, I was also running for the alarm. Same story. Okay, so similar is the forward seal. Okay. Here also, this seal is floating seal. Okay, so here is the lube oil. Here also is the lube oil. So this is basically sealing. And if this particular thing fails, then I will simply shut off the valve here, and this will be coming into action. That is all. Okay. And remember that value 0.2 to 0.3 bar more than the seawater pressure. That is the lube oil header. So here in the manual, I will send you this manual. It is mentioned about this 3S seals. Okay. So it is a good read. Double security type, 4 seals are there. One of them is standby. It all talks about that, right? And what kind of lube oil you should be using. And this is given about the propeller drop. Okay. So we will come to the propeller drop after the stun tube. Okay. So how do you repair? So as I told you, the chrome liner, it can be machined. So this is the tolerance. So if you have a 140 mm chrome liner, 140 mm diameter, so 2.5 mm is the max you can machine. Okay. So it depends on the diameter of the chrome liner. So there is a limit given for machining. Yes. And this is about the bonding repair. I was talking about vulcanizing, right? So here is the vulcanizing thing going on. You can do that. And this is how you asked, right? It has to be done by the shore staff. So somebody will come put up a staging there. He will take the vessel be in the ballast condition, okay, completely out. And then this thing will be exposed and they can work here very nicely. Okay. These are some of the trouble. It is a very good manual. If you actually go through this manual, your exam preparation is very well done for stunting. Okay. So I will send you this manual also. Yeah. So here we have covered about the simplex seal type. Okay. The next in the line, what we have to cover is the air seal. That we will see on Monday and Tuesday. There will be no class, but on Wednesday, yes. What is the date on Wednesday? Wednesday is 17th. Yes. So 17th, there will be 17, 18, 19, 20 probably, yes. 21, I would be traveling. So I am traveling for at least 5 days somewhere out. So I would not be able to take the class. So let's finish simplex seal if possible tomorrow. If not tomorrow, then Wednesday we will finish the simplex seal. Sorry, not the simplex, the air seal. Okay. Air seal and the stern tube bearing. For the exam purpose, simplex seal, air seal, and propeller drop, chrome liner limits. And then one more thing was there. Emergency procedures for the seal. If you studied these 5 topics from the stern tube part, that should cover for your exam. That should be enough. Because I don't see any different questions coming. If at all they are coming, they are framed in a different way. But the answers remains the same. There is nothing much to learn in the stern tube. Is that understood?
Yes, sir.
Yeah, it is a very simple topic. Okay. Air seal is there, but it is with a very small change. The basic remains the same. Okay. So I hope this topic is understood properly. the simplex seal one.
Yes, sir. Clear, sir.
How about the others?
Okay, sir. Clear, sir.
Clear, sir.
Okay.
Sir, if you can throw more light on vulcanizing process in next class, like how it is done, any good
Oh,
material for that, or just
yeah.
sharing group.
Hold on. I will for the vulcanizing. Wait, just hold. For vulcanizing, I have a video as well. Uh, Not here. I will send you a video on vulcanizing right away after this class because I
Okay,
have
sir.
it
Okay,
somewhere.
sir.
Yeah,
Uh-huh.
it is just a 4 minutes video. If you see that, you will understand the whole procedure. It is actual video from onboard. It is on YouTube. Okay.
Okay, sir. Thank you.
Yeah. Okay, then guys, I will see you on Wednesday. Or if I'm traveling on 20th, then probably I will try to have classes on Monday and Tuesday also. I will let you know.
Yes,
Okay,
sir.
see you then.
Good night, sir.
Good night. Good night.
Have a good day.